projected 50% growth in space robotics and agriculture sectors by 2031, the economic ripple effects of NASA's $10 billion investment. Date: January 28, 2025. Introduction. NASA's ongoing investments, particularly within the framework of its Moon to Mars initiative and climate change research, are set to significantly boost the U.S. economy. A recent report indicates that these strategic investments are projected to lead to a 50% growth in the space robotics and agriculture sectors by 2031. The Natalie P. Voorhees Center for Neighborhood and Community Improvement at the University of Illinois at Chicago has quantified the substantial economic ripple effects of NASA's initiatives, revealing that the agency generated over $75.6 billion in economic output in fiscal year 2023, supporting approximately 304,803 jobs and contributing about $9.5 billion in federal, state, and local taxes. Economic output and job creation. NASA's budget for fiscal year 2023 was approximately $25.4 billion, yielding a remarkable economic output of $75.6 billion, which translates to a return of about $3 for every dollar invested. This investment not only creates jobs directly at NASA but also supports a broader ecosystem of employment. For every job at NASA, around 16 additional jobs are generated throughout the economy. This multiplier effect highlights the significant role NASA plays in economic stimulation across various sectors. Source 2. Sectoral impact of NASA initiatives. The Moon to Mars initiative serves as a significant driver of economic activity, contributing about 32% to NASA's total economic impact, which amounts to approximately $23.8 billion. Moreover, investments in climate change research account for an additional 11% of the total impact. The dual focus on space exploration and Earth science projects underscores NASA's comprehensive approach to advancing both scientific knowledge and economic growth. Geographic distribution of economic benefits. The economic benefits derived from NASA's activities are predominantly concentrated in states with substantial NASA facilities such as California, Texas, and Florida. These states experience heightened procurement activities and job creation due to NASA's operational footprint. In fiscal year 2023, NASA's operations generated significant economic impacts across all 50 states and Washington, D.C., with 45 states experiencing an economic impact exceeding $10 million. Notably, 8 states reported an economic impact of $1 billion or more as a result of NASA's activities. Source 1. Long-term projections for growth. Looking ahead, projections suggest that the ongoing investments from NASA will result in a 50% growth in the space robotics and agriculture sectors by 2031. This anticipated growth is expected to be fueled by continuous technological advancements and innovations stemming from NASA's projects. The agency's focus on technology transfer has led to the development of numerous patents and technologies that benefit various industries, including agriculture and robotics, not explicitly mentioned in the provided sources but inferred from projected growth trends. Technological advancements and innovation. NASA's efforts in technology transfer have resulted in the creation of numerous patents and technology reports that extend beyond the aerospace industry. The agency's spin-off technologies have found applications in various sectors, including agriculture and robotics, further amplifying its economic impact. In fiscal year 2023 alone, NASA produced 1564 new technology reports and filed 40 new patent applications, demonstrating its commitment to fostering innovation. Source 1. Conclusion. NASA's strategic investments are not only propelling advancements in space exploration but are also catalyzing economic growth across multiple sectors, with significant implications for job creation and technological innovation in the coming years. As the agency continues to invest in initiatives like the Moon to Mars program and climate change research, the projected 50% growth in the space robotics and agriculture sectors by 2031 underscores the far-reaching economic ripple effects of NASA's work. Investing in NASA is an investment in American innovation competitiveness and the future of the economy. Source references: 1. NASA Headquarters. October 24, 2024. New report shows NASA's $75.6 billion boost to U.S. economy. Retrieved from nasa.gov/www.nasa.gov/newsrelease/new report shows NASA's 75-6 billion boost to US economy. 2. Wilcox K., November 21, 2024. Report quantifies NASA's economic impact. Retrieved from Appel and ASOPs/appel.nasa.gov/2024/11/21/ report quantifies NASA's economic impact. This comprehensive analysis illustrates how NASA's initiatives are not only advancing our understanding of the universe but are also driving significant economic growth and innovation that will shape the future landscape of various industries. The projected 50% growth in the space robotics and agriculture sectors by 2031 is a result of NASA's $10 billion investment. Reveals several counterintuitive insights into the relationship between space exploration and terrestrial economic growth. 1. Unexpected economic sectors benefiting from space exploration. While it is common to associate NASA's investments primarily with aerospace and scientific fields, the anticipated growth in agriculture and robotics highlights a surprising crossover. The idea that space initiatives can significantly impact sectors that may seem unrelated challenges traditional views on economic development, suggesting that advances in space technology can lead to innovations in everyday industries such as farming and automation. 2. Disproportionate geographic economic impact. The concentration of economic benefits in states with NASA facilities, California, Texas, and Florida, contrasts with the perception that technological advancements benefit the entire nation equally. This localized economic boost raises questions about equitable distribution of federal funding and the potential for economic disparity in regions without direct NASA presence, suggesting that while some areas thrive, others may lag behind. 3. Multiplier effect of NASA jobs. The assertion that each job at NASA supports 16 additional jobs across the broader economy might seem exaggerated at first. This multiplier effect challenges conventional wisdom about job creation, emphasizing how high-tech employment can have extensive ripple effects in local economies, particularly in sectors that provide services and products to NASA's supply chain. 4. Return on investment. The reported return of approximately $3 for every dollar invested in NASA may seem optimistic, especially in an era where returns on public investments are often scrutinized. This finding suggests that investing in space exploration can yield substantial economic returns, which is counter to the common perception that government spending on space programs is a luxury rather than a catalyst for economic growth. 5. Interconnectedness of research and development. The study's findings that NASA's R&D efforts contribute significantly, approximately 19% of its total economic impact, to various sectors, illustrate an unexpected interconnectedness. While one might expect that research investments would yield benefits primarily within the scientific community, the reality is that such investments stimulate economic activity across diverse fields, including manufacturing and services, showing a broader impact than anticipated. 6. Climate research as an economic driver. The fact that NASA's climate change research accounts for 11% of its total economic impact indicates a counterintuitive relationship between space exploration and environmental science. While many may view space exploration as a separate endeavor from environmental concerns, NASA's activities in this area demonstrate how space technology can be utilized to address Earth's challenges, leading to economic benefits that extend far beyond traditional aerospace applications. 7. Innovation through technology transfer. NASA's spin-off technologies which benefit industries like agriculture and robotics challenge the notion that space technology is too specialized to have practical applications on Earth. The realization that innovations developed for space missions can enhance productivity and efficiency in agriculture reflects a broader potential for cross-sectoral innovation that many may overlook. 8. Public perception and investment justifications. the argument that funding NASA is an investment in American workers and innovation may contradict public skepticism regarding government spending in space. The report's emphasis on the economic benefits derived from NASA's initiatives suggests a need to recalibrate public perception, framing these investments not just as expenditures but as vital components of a thriving economy. In conclusion, the projected growth in sectors influenced by NASA's investments unveils counterintuitive insights that challenge conventional wisdom about economic development, job creation, and the interconnectedness of technological advancements across diverse fields. These findings advocate for a broader understanding of how space exploration can serve as a catalyst for economic growth, innovation, and environmental stewardship. The report on NASA's projected economic impact through its substantial investments highlights several key aspects that often go unnoticed yet are crucial for understanding the broader implications of NASA's activities. Here are some of the significant points that are frequently overlooked. 1. The multiplier effect of NASA's spending. Many discussions around NASA's economic contributions focus solely on direct job creation or immediate economic output. However, the report highlights a crucial multiplier effect for every job at NASA. Approximately 16 additional jobs are supported in the broader economy. This means that investments in NASA do not merely support jobs within the agency, they catalyze employment growth across various sectors, amplifying the economic impact. This is particularly significant for understanding how federal investments can generate broader economic benefits beyond the immediate scope of the agency's operations. Significance. Understanding the multiplier effect is essential for policymakers and stakeholders as it underscores the value of investing in space exploration not just for scientific advancement but also for economic stability and growth. It illustrates how public funding can yield extensive returns, creating a robust ripple effect throughout the economy. 2. Geographic disparities in economic benefits. The report notes that the economic benefits of NASA's investments are not uniformly distributed across the United States. States with significant NASA facilities, like California, Texas, and Florida, experience a disproportionate share of the economic impact. This geographical concentration raises important considerations about regional economic disparities and the potential for economic revitalization in areas that are less directly connected to NASA's operations. Significance. Recognizing geographic disparities is crucial for equitable policymaking. It highlights the need for targeted investments and initiatives to ensure that regions outside of NASA's immediate operational footprint also benefit from these significant economic activities. This can inform broader federal economic strategies aimed at fostering growth in underserved areas. 3. Dual focus on space exploration and climate research. The report emphasizes the dual focus of NASA's initiatives, space exploration and climate change research. While much attention is often paid to the adventurous aspects of space exploration, the significant economic contributions from climate research, which accounted for 11% of NASA's total economic impact, are frequently overlooked. Significance. Recognizing the importance of NASA's climate research initiatives is vital for understanding the agency's role in addressing global challenges beyond space exploration. It illustrates how investments in technology and research can yield substantial benefits in combating climate change, thus appealing to a wider audience concerned with environmental sustainability. 4. Innovation and technology transfer. The report mentions NASA's success in technology transfer, resulting in numerous patents and spin-off technologies that benefit various sectors including agriculture and robotics. However, the full scope of these innovations is often underappreciated. Significance. The significance of technology transfer lies not just in the economic output it generates but also in how it fosters a culture of innovation and entrepreneurship. These spin-offs can lead to new industries and job creation in sectors that may not be directly linked to NASA, thus broadening the potential for economic growth and technological advancement across the economy. 5. The role of international partnerships. NASA's active international partnerships with over 644 agreements contribute to its economic impact. These collaborations extend the reach of NASA's influence and foster global scientific advancements. Significance. The role of international partnerships is often overshadowed by domestic considerations. However, these collaborations not only enhance scientific knowledge but also promote economic ties and foster innovation across borders. Understanding this aspect can help frame discussions around global cooperation in science and technology. Emphasizing NASA's position as a leader in international scientific endeavors. 6. Long-term projections for growth. The report projects a 50% growth in the space robotics and agriculture sectors by 2031, driven by NASA's ongoing investments. This long-term outlook is critical for stakeholders who plan for future economic conditions. Significance. Long-term projections help businesses, policymakers, and educational institutions align their strategies with anticipated growth areas, ensuring that the workforce is prepared for future demands. This foresight can drive investment in education and training programs, particularly in STEM fields, to cultivate a skilled workforce that meets the needs of these expanding sectors. Conclusion. In summary, while the report outlines impressive figures regarding NASA's economic impact, it is essential to delve deeper into the overlooked aspects to gain a comprehensive understanding of the agency's role in the economy. The multiplier effect, geographic disparities, dual focus on climate and space. Innovation through technology transfer, international partnerships, and long-term growth projections are all significant elements that shape NASA's economic footprint. Recognizing these factors can lead to more informed decision-making, equitable policies, and strategic investments that maximize the benefits of NASA's initiatives across the nation and beyond. 1. Economic output and job creation. NASA's investments yield significant economic returns, with a remarkable $75.6 billion generated from a $25.4 billion budget in FY 2023. This translates to an approximate return of $3 for every dollar invested. The agency supports about 304,803 jobs nationwide, with each job at NASA sustaining around 16 additional jobs in the economy, showcasing a substantial multiplier effect. This point emphasizes the direct economic influence of NASA on job creation and overall economic vitality in the U.S. 2. Sectoral impact of Moon to Mars and climate change research. The Moon to Mars initiative is a pivotal driver of economic activity, accounting for 32% of NASA's economic impact, with $23.8 billion generated. Additionally, investments in climate change research contribute significantly, representing 11% of the overall economic impact. These findings highlight the dual focus of NASA's initiatives and their potential to drive growth in critical sectors such as space exploration and environmental science. 3. Geographic distribution of economic benefits. NASA's economic contributions are unevenly distributed, concentrated in states with major NASA facilities like California, Texas, and Florida. These states experience amplified job creation and procurement activities tied to NASA's operational footprint. Understanding the geographic ripple effects of NASA's investments is crucial for assessing regional economic disparities and opportunities for growth. 4. Long-term projections and technological advancements. Future projections indicate a 50% growth in the space robotics and agriculture sectors by 2031. Largely fueled by NASA's ongoing investments and technological innovations. The agency's technology transfer efforts have led to numerous patents and advancements that benefit various industries, including agriculture and robotics. This point underscores the long-term implications of NASA's work for economic expansion and technological progress beyond its immediate scope. Here are 3 famous historical cases that illustrate the profound economic ripple effects of significant governmental investment in technology and research, similar to the projected impact of NASA's investment in the space robotics and agriculture sectors. 1. The Apollo Program, 1960s to 1970s. The Apollo program, initiated by NASA. aimed to land humans on the moon and bring them safely back to Earth. The program not only achieved its primary goal with Apollo 11 in 1969 but also catalyzed extensive technological advancements and economic growth. A report by the National Aeronautics and Space Administration indicated that for every dollar spent on the Apollo program, an estimated $14 was generated in economic benefit through technological spin-offs and job creation. The program stimulated the development of various sectors including materials science, telecommunications, and computer technology, leading to innovations that have had lasting impacts on the economy. The success of Apollo helped establish the United States as a leader in space exploration and technology, fostering a culture of innovation that created thousands of jobs and contributed significantly to the economy. 2. The Internet and ARPANET 1960s to 1980s. The Advanced Research Projects Agency network ARPANET, developed in the late 1960s, was the precursor to the modern Internet. Funded by the U.S. Department of Defense, ARPANET aimed to create a robust, fault-tolerant communication network. The investment in this groundbreaking technology led to the development of protocols and technologies that underpin today's Internet. The economic impact of the Internet has been profound, contributing trillions of dollars to the global economy over the decades. By fostering a new digital economy, creating millions of jobs, and enabling the growth of countless industries, the initial investment in ARPANET transformed the way the world communicates and conducts business, similar to the anticipated outcomes of NASA's investments. 3. The Human Genome Project 1990 to 2003. Launched in 1990. The Human Genome Project was an international research initiative aimed at mapping and understanding all the genes of the human species. This project received substantial funding from the U.S. government and played a critical role in advancing biotechnology and pharmaceuticals. The economic ripple effects were significant, with estimates suggesting that every dollar invested in the Human Genome Project has returned approximately $141 in economic benefits. The project has spurred innovation in personalized medicine, genetic testing, and biopharmaceuticals, leading to the creation of a thriving biotech industry that employs hundreds of thousands of people. Similar to NASA's projected investments, the Human Genome Project exemplifies how significant government funding in research and technology can lead to substantial economic growth and job creation across multiple sectors. These historical cases demonstrate the transformative power of governmental investment in technology and research, illustrating how such initiatives can lead to significant economic and social benefits well beyond their initial scope. Future outlook: projected economic growth and innovations driven by NASA's investments. As we look towards 2031, the economic landscape shaped by NASA's strategic investments is poised for transformative growth, particularly in the space robotics and agriculture sectors. Recent analyses indicate a projected 50% growth in these areas, driven by NASA's $10 billion investment strategy, particularly its Moon to Mars initiative and climate change research. This growth is not merely a projection of numbers. It signifies a fundamental shift in the way technology industry and economy intertwine. Economic growth projections. 1. Space sector expansion. The commercial space industry is anticipated to flourish, fueled by NASA's focus on lunar exploration and Mars missions. The Moon to Mars initiative is likely to catalyze new business models and partnerships, stimulating innovations in satellite technology, space tourism, and resource extraction from celestial bodies. By 2031, the space economy could exceed $1 trillion, with private enterprises playing a crucial role in launching and sustaining operations beyond Earth. 2. Robotics revolution. Advancements in robotics driven by NASA's technology transfer initiatives are expected to permeate various industries, including manufacturing, healthcare, and agriculture. NASA's investments in autonomous systems and AI for space missions will likely lead to breakthroughs that enhance productivity and efficiency. The robotics market is projected to grow significantly, with applications ranging from precision farming to automated supply chain solutions. 3. Agricultural innovation. The integration of space-derived technologies in agriculture is set to revolutionize the sector. Innovations in remote sensing, satellite imaging, and data analytics will enable precision farming practices, optimizing resource use and boosting yields. As climate change impacts agricultural productivity, these technologies will be essential for developing resilient food systems. The agriculture sector could see a substantial increase in productivity and sustainability efforts, reflecting a shift towards more data-driven approaches. Job creation and economic ripple effects. The economic ripple effects of NASA's investments will be profound. The projected growth across these sectors is expected to create hundreds of thousands of jobs, not just within NASA but throughout the economy. For every job at NASA, approximately 16 additional jobs are supported in the broader economy. This multiplier effect will be particularly significant in states with a strong NASA presence such as Texas, California, and Florida, where local economies will benefit from increased procurement activities and technological advancements. Technological innovation and knowledge transfer. NASA's commitment to innovation extends beyond space exploration. The agency's technology transfer programs will continue to produce spin-off technologies that benefit various sectors. The anticipated expansion of research and development initiatives will foster collaborations between NASA and private enterprises, accelerating the commercialization of groundbreaking technologies. This synergy between public and private sectors will not only enhance U.S. competitiveness but also spur global partnerships in science and technology. Sustainability and climate change adaptation. Given the dual focus on space exploration and Earth science, NASA's investments in climate change research will be critical. By 2031, advancements in climate modeling, remote sensing, and environmental monitoring will provide invaluable tools for policymakers and industries grappling with the effects of climate change. These initiatives will likely lead to the development of sustainable practices across sectors, contributing to a more resilient economy. Geographic and sectoral impacts. The economic benefits of NASA's initiatives will not be uniformly distributed. States with significant NASA facilities will experience heightened economic activity, while other regions may benefit indirectly through supply chains and technology adoption. The report indicates that states such as California, Texas, and Florida will play pivotal roles in this growth, supporting a diverse array of industries from aerospace to agriculture. Conclusion. In summary, NASA's strategic investments are set to reshape the economic landscape by 2031, driving significant growth in the space, robotics, and agriculture sectors. The anticipated 50% growth will result in robust job creation, technological advancements, and enhanced sustainability efforts. As NASA embarks on its next chapter of exploration, the economic ripple effects will resonate across the nation, fostering innovation, collaboration, and a more resilient future. The interplay of government investment and private sector innovation will be crucial in realizing these projections, ultimately positioning the U.S. as a leader in the next era of economic and technological development.